Let's take a look at some examples out of 1.5. So the first problem that we're going to look at, they give us a function, and notice that that function is undefined when x is -2. Also notice that this is a non-removable discontinuity. There's not a way to factor and reduce this fraction so that we can make that discontinuity go away. That factor doesn't exist in the numerator, so we can't cancel. So that factor that makes it discontinuous won't go away. And what happens at non-removable discontinuities, we have vertical asymptotes. So we're asked a couple questions. We're asked, what is the limit of that function as x approaches -2 from the left side? So if we're approaching an x value of -2 coming in from the left side, our y values begin to get lower and lower and lower and lower, and we never reach a point. The closer we get to -2, we're going to be getting closer and closer to -infinity. If we pick a value that's really, 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 really close to -2, this on the left side, the closer we are, the bigger in the negative direction our value is going to get. So we're approaching -infinity. Now, by the definition of a limit, technically the limit doesn't exist. This just tells us which direction we're going. How does it not exist? It doesn't exist in the fact that it's going towards -infinity. Now, if we approach -2 from the right side, so if we start on the right side of the graph and go towards -2, then our y values start getting higher and higher and higher. They're going up in the positive direction, so they're going towards positive infinity. So again, the limit does not exist, but positive infinity describes more particularly how does it not exist. It does not exist because as values get closer to -2 on the right side of -2, our y value, our output, is getting closer and closer and closer to positive infinity, not closer and closer to a particular number. All right, this one doesn't have a picture, doesn't have a graph for us, but they still ask the same things. They ask, what is the limit of this function as we approach 3 from the left side? And then what is the limit of this function as we approach 3 from the right side? So if we don't have a picture, I mean, we could draw a picture, or we could pick values closer and closer to what we're approaching from either the left or the right side. Now let's notice that when x equals 3, if we were to plug 3 into our function, we would still get a 1 on top. 3 minus 3 is 0, and squared is 0. So that's undefined. It's not indeterminate because we don't have 0 on top. So x equal -3 is a non-removable discontinuity. Non-removable discontinuity, and that's a vertical asymptote. So as we get closer and closer to 3, we would expect our graph to go either up to positive infinity or down to -infinity. So let's check from the left side first. So a number that's close to 3 on the left side, let's pick 2.9999. Let's put another 9 on there. So if we take out a calculator and we plug that number into our function, we would have 1 divided by 2.99999 minus 3. And we're going to square that answer. And that's what we're dividing 1 by. When we do that, we get 10 billion. So 10 billion. That's really, really big. And if we get even closer to 3 on the left side, that's going to get even larger and even larger. That's positive, so we're going towards infinity in the positive direction. towards the top infinity, not the bottom one. All right, now let's look at approaching 3 from the right side. So if we pick a number that's really close to 3, that's just a little bit bigger, like 3.00001, we could substitute that in. 3.00001 minus 3, square that and divide 1 by that, and that's also 10 billion. And that's also positive. So as we get close to 3 from the right side, we're getting bigger and bigger, and that's going towards infinity, and that's positive as well. This one, we could have known that it was going to positive infinity from both sides if we analyzed the function, because the numerator is always positive, because it's a constant of 1. The denominator is always going to be positive 2 as long as x is not 3, because when we have a square, anything squared is positive in the real numbers. But the easiest thing to do is plug values that are really close to what we're approaching on either the left side or the right side to see which infinity we're approaching. Now this question asks to find the vertical asymptotes, which is similar to in the previous problem, we were at vertical asymptotes. We were told where they were located. We were just analyzing and seeing that yes, they are vertical asymptotes, because as we were approaching specific x values, we were going to either positive or to negative infinity. And that's what a vertical asymptote is. This problem, they actually want us to find the vertical asymptotes. So remember what made the 2 previous problems have vertical asymptotes? It's because we had a 0 on bottom and something that's not 0 on top. Now, technically that symbol's the sign of an empty set, but what I mean by that is that it's not 0 on top. So let's start out on bottom. What makes sine equal to 0? Well, if we look at the unit circle, if we pick a point on the unit circle, the x-coordinate is cosine and the y-coordinate is sine. So sine is 0 anytime that the y-coordinate is 0. So the y-coordinate is 0 here and here. So at 0 and at pi. And if we keep on going around, this point here is also known as 2 pi. If we keep on going around, this point is also known as 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and it also goes in the negative direction as well. So as long as our input is a multiple of pi, we could call 0, 0 pi. So 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3. As long as it's something, some integer times pi, when we take sine of a multiple of pi, we always get 0. They say use n as an arbitrary integer if necessary. And yes, since there's not just one angle, since it's something that repeats cyclically or periodically, then n times pi describes all of those values where n is an integer. But we have to look at one example. Notice 0. If we put a 0 in, we get 6 times 0 on top, sine of 0, which is 0 on bottom, and that's not a vertical asymptote. That is undefined, but remember that if we get 0 on top, it's not a vertical asymptote, it's a hole. That's a removable discontinuity. So in that case, we can't use the instance where t would be 0, and that's when n is 0. So any value, any multiple of pi except 0 times pi will be okay. But when we have 0 pi, that's not a vertical asymptote. All right, this one we just showed you the answer, but let's take a look at this one. They ask us for the one-sided limit, so we'll do this one more time. They ask us, what is the limit of this function as x approaches -3 from the right side? So let's note, first of all, that when we substitute -3 in, we get 1 over 0, which is undefined. It's not indeterminate because we don't have 0 on top. This is going to be a vertical asymptote, which is a non-removable discontinuity. We can't take that out. So if we want to see, well, are we going towards positive or negative infinity when we're approaching from the right side, just pick an x value that's to the right of -3, but really close. So if we're on the right side of -3, that would be like 2.99. If you get mixed up with that, think about making a number line. So if we're on that side of -3, that's going to be -2 point something. If we're on the left side of -3, that's when we have like 3.1, 3.2, 3.3. So if we substitute this value into our function, we have 1 over the result of -2.99 plus 3, and that gives us 100. That's a positive number. If we pick even closer, this is going to get bigger, but it's still going to be positive for that limit going towards positive infinity. The overall limit itself doesn't exist. It doesn't go to anything in particular, but from one side, it's going towards positive infinity.